Hey everybody, it's Jay Henry. In this video, I am going to try to containerize the service that we built to serve our computer vision model that we've been working on. And this is kind of a big one. It took a lot to get this working. I'm going to try to present it in a very kind of linear fashion, although it was not a very linear process to get it working. Um, and I think the first thing to start off with is, if you remember, we created a separate repository for the infrastructure code. So we could, have the correct separation of concerns between infrastructure and source code. Um, and in this repository, we had everything in our definitions file or definitions directory. And this provisioned all of the infrastructure that we needed for AWS, including our VPC, our security groups, our load balancers, CloudWatch, and everything. Um, and what I've done is, although we still have an ECS resource, a Terraform file here that creates the ECS cluster, I've broken out the parts of the ECS code that create the template, the task definition, and the service into a module. And the reason for that is that we're actually going to import this module into our source code repository, parameterize it from there, and create the new task definition and update the service as our source code changes. And I think that'll make more sense when we get to it, but I wanted to call that out. And all of this is checked into the infrastructure repo that is linked in the description. So if you watch the last video and this looks very different from that, just realize the code's checked in, and you can take a look at it on GitHub. The other, I think, changes we made to this are we created some output variables from Terraform, and these will actually be saved in the Terraform state, the remote state, and we'll be able to use these in our other repo. And so, like load balancer, our target group ARN, the VPC ID is subnet IDs are saved in there. And the only other change I think I made was the ingress and egress. In the last video, I had these set, the from and to ports were both 0, and I mistakenly thought that that meant that all of the ports were open, but that's not what it meant at all. You actually need from and to have the entire range of open ports. And then for ingress, I had it open, I think at either 0 or port 80, but it actually needs to be the port that we're going to call the service on, which in this case is 9001. So, having said that, let's take a look at the source code repository, and let's start making the changes that we need here to be able to containerize this service. So I'm going to create a Dockerfile here, but before I do, I'm going to create a dockerignore. And a dockerignore is, much like a gitignore, and it'll prevent certain things from being sent to the context of the Docker image, which will help keep our image sizes low and not send extraneous, code files or configuration or whatever to our Docker image. And the only thing I'm going to exclude here are node modules and debug logs. So, but if there's anything else that you wanted to exclude from being sent to your Docker file, you could put it in here. So now we can create our Docker file. And the Docker file is going to tell Docker how to build the image that we're actually going to run. And so the first thing we do is tell it, there's a base image. And it's very similar to CircleCi, where we supplied an image and said, use this image as the base for the build. It's the same thing for Docker. We're going to say, use a base image, and then we'll extend it. And in this case, we're going to use an Ubuntu image. I think it's 1804. And basically what we're going to do is build a mini virtualized Ubuntu server. I am sure if you've been programming for a while, you have heard, well, it works on my machine. And a long time ago, I was working with a guy and I said, hey, well, it works on my machine. And he said, well, I guess we'll just ship your machine to all the customers. And, he was obviously being sarcastic, but that's kind of the point is like, what you want to do is actually take the environment where it works, package that up, and ship that everywhere. And that's what Docker allows you to do. And so you'll notice that like we're trying to containerize this service, but the Dockerfile is actually at the root level of our repository. And the reason for that is one of the things that we're going to do is actually take the trained computer vision model and make it accessible to our service. So we're going to copy some files into the context of the Dockerfile. So we obviously want to copy everything from services, and we're going to put that in this is the directory inside the Docker container. So the root, it's going to have a root and then a services directory. We're going to copy our models in as well. We'll say models. And we only want trained. We're not going to send everything from the models directory. We're obviously not going to send the data, but we do want the trained model weights to be in there, and definitions, of course. And then we're going to copy scripts. And we're actually going to need to write some scripts here to do this. And actually, that's a good place to actually stop and create some scripts. So we're going to need a script that installs the additional dependencies on top of this image that we're going to need to run this service. So I'm going to go into scripts and create a new one. We'll call it install.sh. Terminal, new terminal. Probably need to add the executable permission to this. So x scripts install.sh. And I'm going kind of quickly through this because there's a lot of information here that I'm trying to get across in a digestible amount of time. But if I like go over anything too quickly, or you have questions, or there's anything that I skipped or anything, leave me a message in the comments and I'll try to clarify it. All right, so inside install, what are we going to do? We're going to make sure that we're up to date. We're going to upgrade for anything new. We're going to install Python 3.7 and pip 3 because they're used extensively. Let's see, install Python 3.7. Tell it yes. We're just going to answer yes. It's obviously not going to be monitored. It's going to be, a human's not going to be sitting there answering questions during the install process. Python 3 pip. Yep. And then we're going to actually use pip 3 to install some of our dependencies. So we're using Flask. I think we're using Keras. We're using TensorFlow, I think. And you can create a requirements.txt file and feed that into pip and let it like discover stuff through there. And I've done that before, and I find it to be a little cumbersome. This is just a little bit more straightforward for me, but feel free to do it however makes sense to you. And then pillow is for image loading. I think that is it for that. And so what we're going to do in our Docker file, if we go back to there, is we're going to actually run that. So we're going to run scripts, install, and then we're going to set our work directory to be services so that we can do, use relative paths from there. And then there's two kind of funky looking environment variables that we need here. And if we didn't put these in, we'd get an error message that basically tells us that Python 3 and Flask don't play well together, and it doesn't understand what kind of encoding we want to use. And I could do an entire video on that error message and how to fix it. But basically, if you're using Flask and Python 3, add these environment variables so that it can actually run your code. Is really all you need to know. Although I might leave some stuff in the description about like what the error message is and how I found it, because it actually took me a little bit to find the answer. And no need to redo that research if it's already been done. We're going to expose this port because this is the port that our service is going to be running on. And then we're going to give it a startup command, python 3 service.py. Oh, one other change that I made to the services, which is why we're calling this and not Flask run. I actually told it to run. I told it what host to run. If you run it on this host, it'll expose it to the internet. If you run Flask without specifying a host, it'll only be available locally. And obviously we're telling it what port to run in, and I told it not to run in multi-threaded mode. And the reason for this is that inside of our provider, where we are loading our model and then using that same loaded model over and over again for efficiency and speed, if you run this in threaded mode, the second time you try to use that service, it'll blow up and it'll give you this really nasty error about your graph and things not being available. And if you run it in single threaded mode, it works just fine. And that's what this is. And that's why this Dockerfile is not calling Flask run, it's just starting up this file. A note about Docker command: if you supply a command here, you can override this command at runtime. If you were to change this CMD to entry point, it would always run that command. And obviously, like, a full tutorial on Docker is outside of the scope of this, but just it's something interesting to know. If you supply it as a command, you can override it. Okay, I think that is it for the Dockerfile. So we've got Dockerfile, we've got install. I actually think at this point we're ready to create our infrastructure scripts. And this is the part where it gets a little, I don't want to say hairy, but it was a part that was a little bit confusing for me. So what I'm going to do is create a infrastructure folder. And underneath that, I'm going to create a stage folder. And again, when you have, for this example, it doesn't really matter. We could put it directly in the infrastructure folder, but when you want to have a multi-environment setup where you have a dev environment, a stage environment, a prod environment, you're going to want to have different parameter files for each one. So let's see, what is the best way to go? I think I'll just start with the Terraform file. We'll stay stage.tf. And we're going to add a new variable here, which will be needed at the point where we actually run the build in CircleCi. So this part is interesting because this is where we're going to load up the remote state for our other repository. And so this is where we're actually going to be able to access the infrastructure code that we wrote in our other repository and the outputs that we created that we can then use to not only parameterize the module that we're going to create, but also get access to the state of that infrastructure. So the backend for this is S3 because we've stored it in a bucket in S3. And then the config is, we're going to tell it what region we're in. The region is East 1. The bucket is, JNV code vision. No, that's not what I wanted. Code vision, and then the key is stage inf, and that tells us that the state file we're using is the stage infrastructure state. And so we'll be able to use this data later on in our configuration. We're going to tell it what our provider is. Our provider, again, because this can be used in AWS, can be used in Azure, Rackspace, whatever. And we're going to do shared credentials file, just, a file that you have locally configured on your machine so that you don't check in accidentally your AWS credentials. Profile default. If you have multiple profiles, like multiple AWS accounts, you could specify which one you want here, and then region US East 1, you could probably parameterize that. And now we're going to actually set up the state for this infrastructure. I actually store this in a separate state file. I have seen people do it in the same state file. I don't know if they need any magic to make that work. I think you would probably get issues unlocking that file, but just to be safe, I keep it in the same bucket, but I put it in a different state file. JNRE code vision. The key is stage services or service inf.tf state. So it tells me that this is the main infrastructure, and this is the infrastructure that's related just to the service that I'm creating. And again, you could parameterize this region. It seems like a little bit of not very dry. Don't repeat yourself. So I'm going to create a module here. Predictions, and this is kind of the cool part, is we're going to give it a source, and the source is actually going to be a reference to our infrastructure repository. So we're going to tell it JNRE code infrastructure. And then notice the double slash. The double slash is important. It allows us to go in and actually select out the module for ECS that we created before. And so now we'll be able to parameterize that module using the outputs from this remote state. So the security group that we need is going to come from there. Terraform remote state JNRE code vision, and then you have to tell it it's the outputs that you're using, and then which one. Group ID. And if we switch back over to that repository and we look at the outputs here, you'll see these are all the outputs that we're going to be using. So we've got our security group ID, our subnet IDs, our target group ARN, and our cluster ID. And we're going to be using all of those here. I think that is good. We'll say subnet IDs, data, Terraform remote state. I may be able to cheat with some of this stuff. IDs. So let me actually copy this part. I think we can use that to cheat a little bit. Target group ARN, and then we'll just say target group. Yeah, that makes it a little bit easier. And then the cluster. And all of these, all of these resources should be pre-existing in AWS because our build on the infrastructure directory should have created them. ECS cluster ID. I think if you tried to run this after you had destroyed them or they hadn't been provisioned, you'd probably get some pretty nasty errors. And then we're going to set our tag here, and we're actually going to set this in a script that we're going to use to deploy, but we're not quite there yet. That's actually the next step. So what we're doing here is we're saying import this module, parameterize it using these variables, and then this tag is going to be important too, because if you remember from our task definitions, I think we use that tag here to tell it which image we want to pull for this, task. Um, so that's it for that part. I think the next thing we want to do is, we've got a Docker file, and we want to actually build that and push it up to the ECR repo that we created in the last one. So inside here, I'm going to make it a sibling here. It just makes it a little bit easier. I'm going to create a script called push images to stage. Could totally put this in the scripts directory and have everything in one place. It makes the changing between directories a little bit more complicated. And this was just easy. But you could definitely do it either way. So let's make this executable. And we'll do infrastructure stage push images to stage. Okay. And then what we're going to do is we're going to build it. We're going to log into ECR, and then we're going to push it. And so anybody that's ever used Docker, this syntax should be very familiar. We're going to tell it exactly where to push it. And so the account and what kind of service and region and all that is all part of the locator for your service. So we got to put all that in here, and it's kind of a pain, but whatever. We're going to say Docker. We're going to say ECR, Elastic Container Repository, US East 1, Amazon AWS.com, and then vision predictions, and then tag, right? Because we want to tell it which. And here, the tag variable is actually preceded with TFR, and this is a way where you can set an environment variable in a bash script, and Terraform will understand it. And this is where the code lives that we actually want to, the Dockerfile lives, because we're down in 2 directories deep. We want to tell it this is the Dockerfile, and that's dot means the context we're going to send to it. Now we're going to log into ECR. Let's see, ECR get login. Now include email region US East 1, and if you just say get login, it's going to return you a JSON object that you can parse out. This is a way to parse it out all in kind of a one-liner. Let's see. HTTPS. And then I think it looks like that, and that should successfully log us into ECR, and then we're just going to push. And I think we can cheat a little bit here because we've already got this, and so we'll just push that up. You could also do things like tagging it. Like often I will build an image and then tag it not only with the SHA-1 of the Git repo, but also tag it as master or release or something like that. But here I think we'll just do the simplest thing that we can do. And I think that's it for this script. So now what we're going to want to do is we're going to want to create a script to set this variable, initialize and get a plan from Terraform, actually call this script to push our image up to ECR, and then apply our infrastructure. And I'm going to put that in the same place because, again, it's just easier to have it right here. And cheat a little bit here. And so in here, we're going to export this variable, and it's, again, TF bar, and then the name of the variable that you want. And we'll say get rev parse head, and this will give us a unique SHA, I think it's a SHA-1 hash of our repo that we can use as a tag. We're going to want to cd into the directory where the script is so that we can use local path or relative paths infrastructure stage, all of this, and all of this should look familiar from the last video. Plan, and then push images to stage, the script we just created, and then we'll actually apply our infrastructure. And again, this just automates the process of saying yes when it says, are you sure you want to do this? And that's actually all the code it's going to take to get our infrastructure provisioned and deployed. So all that really remains is that we have to, this repository is not yet hooked up to CircleCi. You'll notice there's not a CircleCi directory here. So what we'll need to do is create the CircleCi directory, and let's see, CircleCi, create the config file for it. And then when we push it up to the repo, it should build and provision our infrastructure. So the first thing we're going to want to do here, actually this should all be pretty familiar from the last video, so I'm not going to. Here's an interesting thing about my machine. If I name this YAML, it's probably because of my plugins, it'll do the spacing for me. So I'm going to do it while it's named YAML, and then I'm going to rename it to YML before we push it up. I'm not going to spend a lot of time going over the individual steps here because we did that in another video. CircleCi. But they should look familiar, and if they don't, like, just ask questions in the comments, and I'll try to make sure that I answer those. And again, this is going to be a two-step process, because when we want to add in unit tests, we're going to want to have a build step for that, and probably additional steps for like integration tests and scalability and all that. But for now, we're just going to do that, and then we will create a deploy job. And the deploy job is where most of the heavy lifting will be done. But it'll really just be calling the scripts that we used or that we created already. Let's see. And then the difference being here that the image we use here is going. The image that we use here is going to be Ubuntu, not Python, because we're going to need to install some additional dependencies here. 1805, sure. Working directory, again for relative script paths. Vision, good. And then steps. I'm actually not getting any benefit out of that. That's weird. Let's just go ahead and rename it again. Do it the hard way. So we're going to check out our code. We're going to set up remote Docker, which gives us an isolated environment. Run. And again, this is just like syntactical candy. We're just going to send out a message saying we're deploying. It's not even syntactical. It's just candy. And then, so this is where we're actually going to install additional dependencies that we need for this build. Because we're going to need things like the AWS SDK. I think we're going to need to download Docker. We're going to need things like, I don't know, wget, things like that, I think. Curl, whatever. So maybe this is a good time to create that script. Yeah, let's go ahead and do that. So we'll say install build dependencies. Will that work? I think that'll work. Okay. And in here, we're going to do, again, some very Linuxy things to make sure that we're up to date and that we have the latest of everything. And then we're going to install our dependencies. So this will work. Let's see what else. The AWS CLI, probably need AWS CLI. I think that's right. Apt-get. And then there's just some additional things that we need here. Sudo obviously is important. We're going to be downloading things and unzipping them, so we'll need that. Wget, curl, that kind of stuff. Now we'll start using sudo. It's all software. Properties, common, sudo apt-get update. Oh, that doesn't look right. Okay, and then install transport HTTPS CA certificates. I think this is necessary. Software properties common. Yeah, I think this is necessary. Yeah. Obviously, I'm working off of a script that I previously wrote to do some of this stuff. Oh, I know why it's, yeah. It's necessary so we can download and install Docker. Duh. And make sure that, we're downloading a valid version of Docker. S download docker.com into Bionic stable. Okay. Common update. Cache policy. Docker Community Edition. Nope, just CE, just Community Edition. And then apt install Docker Community Edition. Yep. I think I'd like it more if the answer had to be yep. And so this is our script to install the build dependencies that we're going to need. So we can now wire this up to our CircleCi config. So we'll call bash scripts. And so the reason I put this in the scripts folder instead of here is that it's not particular to the stage environment. Like, this is universal for all builds that we're going to do for all environments. And it's also in the same directory we have our Terraform script, so it's easier to just put those together. I think it makes more sense. Build deps.sh. Cheat a little bit here. We're going to do the same thing for Terraform. And then this step, I actually hate this step, and if you know of a better way to take care of this, please leave me something in the comments letting me know, because this just seems like a big security hole to me. We're basically going to add something to our config file, our SSH config file, that says when you're looking at GitHub, don't be super strict about checking the host keys. And this is necessary for, if you leave this out and you just run this script, you're going to get a message in CircleCi saying that it can't validate the host. And normally if you were running this on like a command line, you would just say yes, add this to known hosts. But obviously, there's no human here waiting to press that button, and so what it does is it hangs your build. But again, if there's a better way to do this, somebody please let me know, because it almost makes me physically ill to do this. Let's see, bash infrastructure. And again, this is where our tag comes into. So we're going to go into infrastructure, and if we had like a prod directory here, this would be prod, and we would go into that directory, and then we would want this, and the reason this calls this file, which probably needs to be lowercase, if we always have an apply.sh, whether this is stage, prod, or dev, it doesn't matter that this is called toStage. The apply file calls it, and so we abstract that away from the build. Apply.sh, and then echo that we deployed successfully, assuming we get this far. And I kind of want to go back to this for a second. Like, this is ugly, and I don't like it, but philosophically, I usually err on the side of getting things done and then tagging those things to be cleaned up later. I would rather ship software than, not ship software. And if there's something that is not a glaring, really bad security hole that's going to cause a problem, I obviously want to fix it, but I don't want it to stop me from getting something out the door so people can start using it. Please tell me in the comments why that's the wrong approach. I'd love to hear about it. Okay. And then I think this should all look pretty familiar. This is just parameterized kind of builds, deploy, env, environment, stage. Nope, just stage. That's what I meant, I promise. And then we'll set up our workflows, which again should look very familiar based on past videos. Version 2. And then we're just going to have a single stage workflow. Jobs will be build. Obviously, we're going to have filters to just the master branch, I think. Filters, branches. I'm really not sure why it's doing 2 spaces in some cases and 4 in others. Oh well. And then deploy stage. Actually, I like a space there. I like an extra line there. Ooh, that's ugly. Let's try that. Okay, deploy stage again. Filters, branches, only master, and then we're going to add also our dependencies here. So it requires that the build step completed successfully. And that doesn't mean anything right now because we're not doing anything, but when we hook up testing steps to this, it'll be pretty meaningful. I think that's it. I've typed a lot of stuff here, and there's a lot of weird formatting things that can go wrong with, and actually I think this might be wrong, with CircleCi. So I think what I'm going to do here is I'm going to pause the video. I'm going to push this up to CircleCi and make sure it builds correctly, and then if it doesn't complain about anything, I'll start the video and kind of walk through what happened. And oh, before I do that, I should show that I have nothing up my sleeve by showing you what's currently in AWS. So let me pull up the ECS. We don't, let's see, do we have a cluster here? We don't have a cluster here. We don't have task definitions. So we don't have a cluster here, probably because we're not in the right region. If we go to our region, we should see that we have a cluster, but we don't have any services, and we don't have any tasks, and we should have a repository, I think. Yeah, but maybe it doesn't have any, it does have an image, okay. we'll go back and we'll keep an eye on this and see if it creates any services. So I'm gonna pause the video here, and we will come back once I've validated that this is going to work and we don't have any syntax errors, and then we'll kind of walk through it. So stand by. Okay, so it looks like the build succeeded. Our infrastructure was deployed. This is, a really long log, but in essence, we created a service and a task definition and deployed them to ECS. You can see them running here. And one thing I did have to do was add a health check so that the load balancer could check and make sure that the service was still up and running. So let's check it out and see if we can actually call this thing. And I think what we need to do here is code jhenry code vision. We're going to use some of our validation data to just test this service and make sure that it is returning predictions to us. Plant maturity, sure. Juvenile, let's go there. And then we're actually going to, I've got a command here copied that I'm going to use to test this, and it'll hit our service. I think if we change our data, we should get a different prediction, maybe. And we do. So it looks like our service is running pretty well in AWS. Obviously, we would want to put some DNS in front of this. And this isn't, the fastest service in the world. Maybe in a future video, I'll use TF serving to serve our model, which has, a ton of built-in optimizations to make it faster. But I think for now, this has accomplished what I was trying to do. So I'll get this checked in. If you want to check out the repo, I'll leave it in the description. And, if you found any of this useful, please like and subscribe below. And if I did anything wrong, any glaring holes, or just anything you see that could be done better, please mention it in the comments so that I can learn something. Otherwise, thank you for watching, and we'll see you next time.